Oh, I guess I should also ask, did anyone have any questions from the dilutions worksheet? How many of you thought through the questions to see if you could actually like reason through them as well as just using the formula?
It's tricky. Sometimes it was
You don't always have to use the formula. You can just think your way through it.
some parts they're like add these.
Yes, right? So a lot of things with those dilution questions become partly a reading thing where you have to like really look quite carefully at the question, see what it's asking for and things like that. Okay, well, if we don't have any questions from that, this is page 68. And if you are given pH, how can you find the concentration of hydrogen? Let's take a look at this. So we have, if we're given the pH, which is 14, how do we find the concentration of hydrogen, which is 10 to the negative 14 molar? See if you can remember that. Remind your partner. Page 68. And let's look at another one. If we have concentration of, if pH is 11, then hydrogen ion concentration is 10 to the negative 11 molar. If pH is 9, concentration of hydrogen is 10 to the negative 9. If pH is 3, concentration of hydrogen is 10 to the negative 3. So what would a formula be that you could use to find concentration of hydrogen? 10 to the negative pH. Okay. Now, if you are given hydrogen ion concentration, now you may or may not know how to do this depending on your math background, but a lot of you probably can because it's second semester in grade 12, and I know a lot of you have taken pre-cal 12, pre-cal 11, things like that. So here we have, if concentration of hydrogen is 10 to the negative 7, then pH is 7. So how do we go from here to here? Anyone know? We take a log. Yes? Log base 10 of 10 to the x is equal to, log base 10 of 10 to the x is equal to x. Yes? Yes? Yes. Now, we're not going to write the base 10. We're just going to assume that if we write log, and we haven't written anything, so log of 10 to the x is equal to x. So what if we had, so if concentration of hydrogen is 10 to the negative 7 molar, what if we were to take the log of the concentration of hydrogen? What would that equal? That would be the log of 10 to the negative 7, which would be what? What's the log of 10 to the negative 7? Negative 7. Is that the pH? Is the pH negative 7? No, the pH is 7. So what would we have to do to this? We would have to change the I don't want negative 7. What do I want? Positive 7. How do I change from negative to positive? What do I do? I multiply it by negative 1, right? Or whatever. So all I'm going to do is I'm going to say, I'm going to make this negative. Yes? And that makes this negative, and that makes this positive. Yes? So our formula then is that and this is equal to the pH. So pH is equal to the negative of the log of the hydrogen ion concentration. Yes? Is good? Okay. You are responsible for memorizing this formula. Okay? You are also responsible for memorizing this formula. And the good thing is that once you have got those formulas, it's actually like some really simple, cheap marks. You know what I mean? It's like, oh, find the pH. Okay, I can do that. Whoa. Where did you go? No, come back. Okay, there we are. Now, here's a question. If you are given the pOH, now instead of pH, what if we're given the pOH and we want to find concentration of OH minus? Tell your partner, how are you going to find that? I don't hear anybody telling their partner. How did you find pH? Or sorry, how did you find hydrogen? 10 to the negative pH. How are you going to find hydroxide? 10 to the minus pOH. Now, do you remember what a pOH is? It's the same as the scale pH is for hydrogen, but it's for hydroxide. Okay? So it tells you about the basicity of something. If you are given the concentration of hydroxide, how can you find the pOH? pOH is equal to negative log of concentration of the OH. You can almost think of the P stands for the power of 10. Does that make sense? Because if you have concentration of OH is equal to 1 times 10 to the negative 6, then the pOH would be, you say, what's my power of 10? My power of 10 is negative 6, but I just have to make it positive. Is good? Okay. So far, we've only done things where our power of 10 is like 1 times 10 to the whatever, right? So that's been, I think we do not need to do any of that. This I took out because it was confusing. So we're going to be on a different page now. This is super exciting. Oh, I'll keep going. Okay, the relation between H, OH, pOH, KW, and pKw, which is on page, let's see, 2B, 23? 72, 73, page 73. Yeah. So today we're going to learn all the math associated with this, okay? And we already know how to go back and forth between hydrogen and pH, and we know how to go back and forth between hydroxide and pOH. Now, and did we learn about KW last day? Just a little bit? Just a tiny bit. KW is the Ka for water. Okay? So KW is the Ka for water. All right, so The log of 10 to the 1 times 10 to the negative 5 is negative 5. So the log of 10 to the 7 is log of 10 to the 7. 7. Log of 10 to the negative 3? Negative 3. Log of 10 to the 1 times 10 to the 4? 4. Now, what if we have a different number? How would you find the log of 5 times 10 to the negative 5? Super difficult. You say, oh, look, on my calculator, there's a button that says log. So I'm going to type in log 5 times 10 to the negative 5. So I would like you to try that on your calculator, please, to make sure that you know how to use your calculator with both scientific notation and your log button. You should get 4.301. Yes? Is that what you guys are getting? Anyone not getting? Would like a little coaching on there? Oh, my goodness. Okay. So all you're going to do, you're just going to cross out the end of log that. See what 5 times the answer is. Negative 5. Okay? Okay, because the number 5 times 10 to the negative 5, this is because it can be rewritten as 1 times 10 to the negative 4.301. That's literally what that means. Okay? Do I care if you understand that or not? No, not really. It's chemistry 12. Go understand it for math class. Okay, if you understand it, it might make things make a little more sense, but really there's not much to it. Now, chemists thought this was a pretty good idea, but they don't like having those negative signs. So they said pH is going to be the negative of the log of hydrogen. Or, what's another way we could write that? Thank you. Yeah. pH is equal to the negative of the log of, what's the other way we could write it? H. What's the other way to write hydrogen ion? Instead of hydrogen, you could use hydronium. Because the hydronium is reality. This one is the short form. Okay, so in reality, if you're in water, is there any H plus floating around? No. In reality, if you're in water, it's H3O plus. Could you please calculate the pH of H3O plus? And actually, we're going to do this one together because I want to show you all that you need to do to get to do the work. Okay? So you actually need to show the formula. So you would write pH is equal to negative log of H3O plus. So you get a mark for the formula. Equals negative log of 3.0 times 10 to the negative 3. Get a mark for plugging in. And then we say 3 times 10 to the negative 3 log. And you should get 2.2 2.5228. Or something along those lines, 2.5229. And now we get to the only thing about, pH that is tricky. And that is significant figures, okay? Now, let's go back and look at our other numbers here, yes? We had 10 to the negative 3. If we take the log, we get negative 3, right? If we have 1 times 10 to the 4, we get 4. Now, do we count the exponent when we're counting sig figs? No, we don't count the exponent when we're counting sig figs. And guess what that number 4 is? That number 4 is the exponent. Yes? So the number in front of the decimal is the exponent. And if that's the exponent, is that a sig fig? Not a sig fig. So that would have 0 sig figs. If I just wrote pH equals 4, I would be like, oh, not a sig fig. So what I have to do then is I would have to say to correct sig figs, we have 1 sig fig here, yes? So I would have to write 4.0 because this is the exponent. And then this is 1 sig fig. So for whenever we've done a log on something, we start counting significant digits after the decimal. Numbers before the decimal are the power of 10. Okay? So let's go down to that previous question. Okay, actually we could do, no, that's fine. Yeah, here we go. So we have 3.0. How many sig figs? 2 sig figs. All right, now remember that this represents the exponent. Yes? Even though it's a 3, it's only a 2 because there's like extra stuff in front of that. There's a coefficient, right? It's because we've got 3 times 10 to the minus 3 that exponent becomes a 2. Does that make some kind of sense? And if it doesn't make 100% sense, it's okay. Don't try and like thoroughly understand it unless you're a math person, okay? Now, what you need to know as a chemistry person is that you need to have 2 sig figs, and if that's the exponent, then these are our 2 sig figs. Okay, so that's 2 sig figs. So what we would do then is we would round this to 2.52 has 2 sig figs. Is good? Okay. So that's really the only tricky bit. And I'll keep harping on it, okay? So only digits after the decimal point are significant in a logarithmic number. Okay. How about you guys try these? Write the formula for pH each time. You might as well. You have to memorize it. and see if you can get them to correct sig figs. So you can check your answers with mine and see if you get the same numbers, and then you can decide on your sig figs, how many there should be. And then if you feel really clever, you can decide if you're acidic, basic, or neutral for each of them. Oh, that should be a 7. Yes, you're absolutely correct. Now, one thing I'd like you to notice about these first two is that they actually have the same coefficient, yes? Right? They're both 5.4 times 10 to the something. And what do you notice is the same about them? The part after the number, because remember, the first part is the exponent. In front of the decimal, that's that part. And you see how 11 is really close to 12 and how 6 is really close to 7. And if we had a 1 at the front, it would actually be that number. But because there's the coefficient is something other than 1, then we'll actually end up with 1 power less. Now, I put this next example in because I wanted to make sure that you felt good about the fact that you can have a what kind of pH? Negative pH. It does exist. It just means that the concentration is very large. Very acidic, very concentrated. Now, it's hard to go past that pH because, for example, yes, yeah. It's hard to go past that pH because, say, for example, hydrochloric acid maxes out at about 16 molar. Like you cannot make it more concentrated than that. It's like it's a saturated solution. So it's hard to go below a pH of about -2, but it does exist. Okay, so this would be negative. And how many sig figs should we have here? 1, 2, 3. So that's going to be 1.176, 3 sig figs. And I did the next one because guess what? Your pH scale can go above the number 14. Okay, so here we have 2 sig figs. And so this is 16.72. And let's take a look at each of these pHs and decide, is the solution acidic, basic, or neutral? Did I make a mistake? You guys got a question? No? Okay. So, 11.27, acidic, basic, or neutral?
Basic.
Basic. 6.27, acidic. We're not going to say weak or strong because it could just be dilute, right? Negative 1.176, acidic. And 16.72, basic. Okay, so that's good. And now we are going to learn this thing called the auto self. Auto means self. So if you have an automatic something or other, it does it itself. Yes, an automatic dishwasher washes the dishes itself. You don't have to do it. So auto means self. So auto-ionization of water means that water is ionizing itself. Now, you guys have no idea what shorthand means. So I'm just going to write short form. Do you guys know what shorthand is? Back before my time, they would actually teach people to write shorthand, which is like a series of symbols and things that stand for syllables and words. And it would mean that you could take dictation very quickly. So someone would speak and you could write your notes very quickly because you weren't writing entire words. You were just writing like syllables or words or things like that. And it used to be very useful for, say, a secretary. There used to be a job where a secretary would actually, like, someone would talk, the secretary would take the shorthand, and then they would type up on the typewriter, ding, chunk. You ever heard a typewriter go ding? Have you ever seen a typewriter? Okay, anyway, they are super fun. So actually my favorite class when I was in grade 9 was typing 9, and we would type along to music, and then and then it would go ding, and you'd slam the carriage, which it was great fun. Anyway, shorthand is those little symbols, but we're just going to call it short form because you probably aren't going to remember what shorthand is. So the short form method is where we just take water And what state is water? A liquid. And it actually does dissociate a little tiny bit. What would it dissociate into? H plus aqueous plus OH minus aqueous. Now that's our short form. What do you think happens in reality? In reality, we don't usually have areneous substances other than our metal hydroxides, which are areneous bases. But mostly things in reality are Bronsted-Lowry acids. And if we have water acting as a Bronsted-Lowry acid, we can also have water acting as a Bronsted-Lowry base, because water is, what's the word? Amphiprotic. Okay. Now, who are our products going to be? Hydronium, because we have a hydrogen transferring from one to the other, so we end up with H3O plus OH minus, aqueous. So that's water. So in the reality equation, water is acting as a Bronsted-Lowry acid and as a Bronsted-Lowry base. I realize I have written Bronsted-Lowry acid, and Bronsted-Lowry base. I'm very sorry. Therefore, water is amphiprotic. Using those two equations, you are going to write the KEQ for the autoionization of water. Two different ways. One using equation number 1 and one using equation number 2.
Yes.
Hopefully, your equations look like this. Yes? And the other one would look like this. Why have we not included water? Because it is a liquid, and we do not include liquids in our KEQ. All right. This expression is known as KW. Okay, so instead of KEQ, we can call it KW, and KW is really the Ka for water. KW is the Ka for water. And if we go to our data booklet, look at that. We know the value of Kw. Yes, it is 1.0 times 10 to the negative 14. So if you know hydrogen, if you knew hydrogen and you know that Kw is 1 times 10 to the negative 14, you can solve for the concentration of hydroxide. If you know hydroxide and Kw, you can solve for the concentration of hydrogen. that allows you to go back and forth between hydrogen and hydroxide. Okay, so let us try this one out. So Kw is equal to the concentration of H3O plus times OH minus. And we also know that Kw is equal to 1.0 times 10 to the negative 14. So what we do is we solve for OH minus. So that would be Kw divided by H3O plus. Are we good with that algebra? Yeah? Are we good with that algebra? I'm asking too soon. You guys are still writing. I'll ask again in a minute. Are we good with that? Okay. And then we just plug in our numbers and we say, oh, well, hey, I know that Kw is 1.0 times 10 to the negative 14. And I am told in the question that H3O plus is 3.0 times 10 to the negative 3. And so I have 1 times 10 to the negative 14 divided by 3 times 10 to the negative 3 equals, and we get 3.33. Times 10 to the negative 12. How many significant figures should be in our answer? Two sig figs. So we want to have 2 sig figs, 3.3 times 10 to the negative 12. Am I done? Molar. Okay, so if you are given hydroxide, you can find hydronium. If you are given hydronium, you can find hydroxide. Easy? Do we like this? Yeah, it's pretty good. Like, I mean, honestly, if you get a question like this, you'd be like, oh, I like that one. Now, since pH is equal to the, what is the formula for pH? Everyone write it down. What's the formula for pH? Start with a negative. We have a negative. And then what function do we take? We take the negative of the log of the H plus. And so therefore, pOH would be the negative of the log of OH minus. So could you please find, and we're using these values from the last question, okay? You'll notice we have 3 times 10 to the negative 3 molar, and we have 3.3 times 10 to the negative 12 molar. So these are from the last question. Could you please find the pH and pOH from the solution in example number 2? Now, once you've got your answers, make sure you've done them to the correct sig figs. I haven't yet. How many sig figs should we have in our pH? 2 sig figs. So my final answer would be 2.5, yes? No, it should be 2.5, 2, because only these are significant 2 sig figs. All right, and 11 point, what? 48. Now, what do you notice about the numbers 2.52 and 11.48? What happens if we add those? What do we get? We get 14.00, because if you remember from last day, pH plus pOH is equal to 14. Okay, so we now have a whole bunch of relationships between things. We can go from pH to H, we can go from H to pH. Find the hydroxide ion and pOH of the following solutions. So H plus is 5.4 times 10 to the negative 12. We want to find the concentration of hydroxide, and we want to find the pOH. Can you do that? It's already solved for you on the paper, but you might want to take your own paper and see if you can do it. There's paper at the back of the room if you would like. Now I have to be honest with you. When you get your concentration of hydroxide, did you guys get the same thing as me? Did I do it correctly? Or did I get it wrong? Nobody's telling me anything, so I'm going to try it again. 1.8 times 10 to the negative 3. Yeah, 1.851. Now, 2 sig figs in that answer, yes? Should I use 2 sig figs when I'm calculating the pOH, or should I keep extra digits? Keep extra digits. Just in case. It may or may not make any difference. And how many sig figs should we have in our final answer? Two. We should have 2 sig figs. Is that good? Yes. Is good. Now, do we need to do example 5 or are we okay? Because example 5 is pretty much exactly the same. Are we good? Okay. Moving right along. Do we need to do example 6 and 7? They're pretty much exactly the same. Would you like to do them or no? Because, whoa, what happened here? Come back here. Example 6. If I give you hydrogen and I ask you to find the concentration of hydroxide and the pOH, could you do that? Would you like to practice it, or do you want to move on to the next thing? Practice it. Okay, do number 6. Do example 6. Do you want me to come and see if you know what you're doing? I might do that. I'll wander around and see if you know what you're doing. Welcome back. How was your trip? Good, good. So we'll need to talk at some point about all the tests and the quiz and whatever. Yeah. But you might need a day or 2. Or a week. Something like that. Yeah. What is it, value? Oh, okay. Thank you for that. Well, here. I'm going to say what is the value of pKw? at 25 degrees Celsius. Okay. And if you do number 16, or so number 6, you can try number 7. Okay. Mm-hmm. Yeah, because there's no particular law that we can place here, it's just normal systems. Okay, folks, for the first part of the question, when you're finding the concentration of OH, sig figs are just like normal because you haven't taken a log yet, right? Yeah. No, because it's a plate. And remember, in phase, we don't worry about it. Yeah. Because look, if you did that, you'd be like milliliter over mole or 1 over water. Right? So when we're doing calculations with a K, we just don't worry about the molar unit. Yeah. But the final answer should be molar. Yeah. Yeah. Now, if you were calculating hydroxide here, how many sig figs should be in your answer? 2, because you've only got 1.0 times 10 to the negative 14. Ooh, that was ugly. Did you guys get 15.18? Yes. Extra digits for the OH. Yeah, I put in the 6.6 repeater. I just used whatever was in my calculator, like it was up there, and so I just pressed log and didn't worry about it. So yeah, I always keep like at least 1 or 2 more digits. Usually 2 is safe. Okay. I know there's one question in this course somewhere in a quiz where if you don't keep 2 digits extra, you'll get a rounding error. Most of the time you're okay with 1 though. Like honestly, if you're just like, I don't care, it's a half a mark, I'll lose a half a mark somewhere and you just want to keep 1 forever, that also works. Okay, I'm not going to do number 7. You can do number 7 if you want to. It's in the answer key. Okay, it'll be the same work though as before. So we know the following things. Yes? Oh, look, we have a new one. If we want to, we know that the negative log of H is pH. We know the negative log of OH is pOH. So guess what? If we take the negative log of Kw, we get pKw. Yes? Now, at 25 degrees Celsius, and remember I keep saying at 25 degrees Celsius for your Kw. Kw is 1 times 10 to the negative 14. That will not be true at other temperatures, because what does temperature do to a KEQ? Changes it, okay? So let's see what happens if we play with these a little bit. Okay, so we've got, if H3O plus is 1 times 10 to the negative 5, what is the OH minus? You might actually be able to do that one in your head. If H3O plus is 1 times 10 to the negative 5, hydroxide would be, can you do it in your head? Challenge. 1.0 times 10 to the negative 9 molar, because Kw is 1 times 10 to the negative 14, and negative 5 plus negative 9 is negative 14. Yay! Okay. All right. What is the pH and pOH? What is the pH of this solution? The pH would be, hydrogen is 1 times 10 to the negative 5. The pH would be not negative 5, but positive 5. And what would the pOH be? 9. Okay, 5 and 9. What happens, and actually, if you look at this, we've gone with the sig figs, because remember, we have 2 sig figs, 2 sig figs, 2 sig figs, 2 sig figs. So what do we get when we add the pH and the pOH? We get 14. We can go into why, but it just has to do with logs, okay? So we're just going to be like, yay, you're not responsible. You can read it if you want to, yada, yada, yada. The only thing you're responsible for is this. Yes? So pKw is equal to 14.00 at 25 degrees Celsius. But because it is related to a K, it will change with temperature. Now, this little chart coming up, I would say memorize it. Memorize it. Super useful. Okay, and we'll actually add on to it in a little bit. Okay. But you know that if you have hydronium and you have Kw, what can you find? You can find hydroxide. So Kw will get you from hydronium to hydroxide, or the other direction from hydroxide to hydronium. We also know that if we have hydronium, we can find the pH by taking the negative log of H3O plus, right? and that'll give us our pH. That takes us down. Now, do you guys remember how we go back up again? How would we find the concentration of H3O plus given the pH? Do you remember that one? 10 to the negative pH. So if you're given pH, you can find hydronium by taking 10 to the negative pH. And in a few minutes, we'll actually do that with some numbers that aren't like 1 times 10 to the negative 4, so that you can practice pushing the button on your calculator. Okay, now going from OH to pOH, negative log hydroxide, tell your partner, how would you go back up again from pH to OH? OH is equal to 10 to the negative pOH. And then finally, going back and forth along the bottom, we know that pH plus pOH is equal to pKw. Now remember pKw, what's the value of pKw? 14. And you can stick as many zeros on that as you want to, really. And what's the value of Kw? 1.0 times 10 to the negative 14. So I would go home and write out this chart about 16 times. Do you know what I mean? Just make sure it's in your head, that you have all those formulas at your disposal, because you should be able to use them. All right. So this is just going blah, 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 blah. And we came up with this formula here. There is another way of writing it. H is 10 to the negative pH. You can also write it as H is the antilog of 10 of the negative pH. So I actually find this one much easier to remember and write. So I usually use that one, but if you like the terminology antilog, you can do that. And the reason that's kind of nice is that the button you're going to use on your calculator to do that is usually shift log. It'll do the anti-log. It will unlog it, essentially. Okay? So let's take a look. Actually, just before we do, let's take a look. Our pH is 4.0. How many sig figs? How many sig figs in 4.0? 1 sig fig, right? Because sig figs are only after the decimal in pH. Okay, so it matters going backwards as well, okay? So we have 10 to the negative 4.0. So that's 1 times 10 to the negative 4, and we have 1 sig fig here. How many sig figs in the pH value for? Oh, we just did that. 1 sig fig, only after the decimal. 1 sig fig. I don't want to do the next one. Let's do this one here with the star. Okay. If the pH is 7.320, then hydronium ion concentration is the antilog, in other words, 10 to the negative pH. And so our pH is 7.320, 7.320. And I would like you to try plugging that into your calculator. Okay. And usually it will be, you're going to be finding the 10 to the X button, which is usually the shift of the log button. Let me know if you cannot find it or if you need help making it work on your calculator.
And once again, on that calculator, you're gonna take the number in first, and then type in. Okay.
Now, most of your calculators, you're going to do this way. But if you have one of these little babies, you would type in this first and then do shift log. Because these, you put the function at the end. If you wanted the square root of 9, you'd type in 9 square root. If you wanted the log, you'd be like blah, 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 log. At any rate, make sure you can do that. We end up with H plus is equal to 4.73630092 times 10 to the negative 8 molar. How many sig figs should be in our answer? 3 sig figs. So we're going to say, okay, I need to have 3 sig figs. So that is then going to become 4.736 times 10 to the negative 8 molar. Is good? Okay. There's our chart. And your homework is going to be to do these exercises on pages 80, 81, 82, 83, 84. Okay, should we just say 80 to 83?
Yeah.
Pages 80 to 83. What's that? Oh, they're not the right pages. Hang on. Oh no, hang on. Pages 79 to 82.
So we're going to go and we find the calculator online. Okay, you're going to say, please start. No, now, yes, because start the calculator. I'm gonna try and vote. Yeah, something like that. Yeah, anyway. What I think like I'll do it one piece. Because otherwise yeah. So if you had like I don't have it, but it will show you the vectors. They are around correctly. It's like just sort of like you forget after you know. Yeah. I'll have to check. Okay, yeah. Program is to sweep it to allow for like a condition factor. It won't let me do it. So your final grade will never look like what it's supposed to be. It'll give you whatever, and then I have to take an assignment where I say all your percentages, like every 2%, and add 3 manually, and then I post that. Just make it absolutely. Pardon me. How am I gonna look at this? I don't know if they will be, I have a place this week. No, that's what I'm sad about. It looks like. Yeah, we'll probably have a place this week. You know?
You know what the fact is? I want you to know this. Good job.